Hello YouTube. I know it's been a while since I haven't posted about my fourth axis, and I thought that now I have enough footage and experience to show you something about my fourth axis. Not quite what I wanted, but at least I want to give you an update on what's been going on since my last video about it. Okay, so here I have some parts made with fourth axis, and I'm gonna tell you the story of them. Notice that I'm covering this with my hand. So this was the first cut that I've made with fourth axis. The finish is very nice, and I wanted more. And in the last days, I mean from November, since I made the last video, I've been working on my new UI for LinuxCNC, made in Python and Qt PyVCP. This was made with Mocha, and I wanted to give it a try to my UI. And this is what it came out, a crash. This is because I had a bug in the tool change, and it canceled the tool length offset, and when it started it just plunged in and broke the end mill. Okay, I worked more on UI, and after a few more weeks, maybe a month or so, I said, okay, let's do another test, the ultimate test. Now the UI was fine, so we have this part. This is stainless. Notice how it looks. The finish is beautiful. You may wonder what are those. You're gonna find out in a second. And crash again. This time my code was fine. I mean, my UI was fine, but this happened because of a bug in Fusion. I had two operations. I had a 2D adaptive and a 2D contour, a wrapped 2D adaptive, and the Fusion post-processor for LinuxCNC has a bug. In case that when it outputs, I mean, when it finishes the first operation, it has a condition that says if it's rotary axis, cancel tool length compensation. So the first part of the milling went well, but the second one, after it finished the first operation, it just plunged into the part and destroyed everything. So I destroyed a collet, I destroyed the ER nut, and I crashed the machine not once. I mean, that was the first crash, but then I crashed it again, and that was due to a config issue in my LinuxCNC. It was a scenario that I didn't handle properly. So in the next in this video, I'm gonna tell you, at the end of the video, I'm gonna tell you more about what I've done to fix that issue. So next, I'm gonna show you some bloopers video of how it went. Unfortunately, the quality of the sound is not okay. That is the reason why I wanted to repeat that video, because I had the I had the mist coolant. It was hissing, and I tried to make a better sound, but unfortunately I just managed to crash the machine. So for the second part, I needed the mist coolant, and I needed to be quite I mean, I needed to turn the lubricant on, not just air, because it was machining stainless, and it was getting hot. So I wanted to maximize the chances of cut in despite the fact that the sound was bad. So before seeing the videos, I apologize for the quality of the sound, but I think you will be able to figure it out how it sounds, and in my opinion it sounds very well. It doesn't have any chatter. I mean, in the first video you might hear some chatter, but that was due to the fact that the back clamp of the rotary axis was not clamping properly. So after I fixed that, no play, no nothing. So follow me, stay with me in the next part of the video, and I'm going to show you more details about what happened. So with the finger on the stop button, because I'm testing the new UI and the new rotary axis at the same time, I'm gonna do this first test cut with these 4 axes. So let's begin. Okay, so here we have the program. It's loaded. This is my new interface that I've been working on for a while, not quite done yet. And here is the setup. So that's a piece of stainless steel, and I'm gonna see how it goes. This is the first test. I hope I don't break the endmil. And I broke it. Okay, attempt number 2. Okay, so next I'm gonna show you what was the problem from Fusion 360 post processor and why my machine has crashed. So I'm gonna hit post process. You can see here we have 2 operations, a 2D adaptive and a 2D contour. Okay, 2D adaptive went well, but then when doing the 2D contour, all was messed up. You can see I'm using the same tool, the tool 1. Okay, so now I hit post process. It's gonna generate the program for me, and I have already loaded this program. So you can see here is the program to the adaptive, and I'm searching for a G49, which means cancel to length compensation. And we have the first G49 after the 2D adaptive, right before the 2D contour. So after the first operation, it's gonna cancel the 2 length compensation. So that's why it crashed. And I have another one, another G41 at the end of the second operation. Okay, I'm gonna close this program and I'm gonna show you what were the changes that I've made. So what you're seeing here is a post-processor edit. This is a trick I learned from NYCCNC, John Saunders, which has a video that I'm gonna link in the description about how to edit the post-processor. You can add an extension into your Visual Studio Code. So I installed Visual Studio Code, and I have a post-processor utility from Autodesk, which allows you to change the post-processor so that you get the code that you want. First, I'm gonna go through fixing that G49 issue, and then I'm gonna show you other changes, other improvements that I've made. Okay, so I'm gonna scroll to that. Yeah, I'm gonna search a G49. No, I'm gonna search a 49 actually. What we see here, it's a G motion model, so this will output a G49. And this says something like, if it's multi-axis, in my case, if I have a rotary axis, output G49. What I'm gonna do, it's comment this line. So I'm gonna double slash this. So this is a comment, and I'll add another comment saying that okay, so now I have this commented, so it will not output a G49. I'm gonna save this, and as you can see, the path of this, it's in the root of the project. So now I'm gonna select that post processor. Right now I have two post processors, and I'm gonna select that one, and I'm gonna say something like browse, and I'm gonna select posts, and this is gonna be the folder that is gonna take the post from. And here we can see LinuxCNC with optional 4th axis. Once I select this, I can see here my custom options. Has 4th axis, you can enable disable, enable pet blending, and go to predefined position. I'll go through this later. Okay, now I hit post. Yes. And if I seek for a G49, now there is no G49 output. So this is how you can change your post processor to not output G49. I will link in the description the changes that I've made to this post processor and the post processor file. There's a link to my GitHub. I will add this link. So if you want, you can take my post processor and use it as you need. Okay, next I'm gonna show you what other changes I've made. So we are just gonna address those red lines. Those are the file changes that we have. So first of all, I have added an optional word here. Then I created, so we have a flag that will allow us to enable or disable the 4th axis. This will prevent a G080 being written at the beginning of a program that doesn't have a 4th axis, doesn't need a 4th axis. So if you don't have a machine that has a 4th axis, you need to set this to false from Fusion before posting the program. So when you post the program, you will need to set this to false. Okay, then go to predefined position. I wanted that when my machining is done, I wanted the table to move to a predefined position. So G30 in LinuxCNC allows you to set a position, allows you to go to a position that was previously set, that's in the machine coordinates. So you can store a position, a predefined position, and when you call G30, it will go to that position in machine coordinates, in absolute move. Okay, so another option was path blending. I had a few parts messed up due to path blending being off. So path blending is G64. I recommend you to go and seek the documentation of G64 if you're interested, and if LinuxCNC is your main, it's your controller. Okay, some of the changes I will cover this later. So another change that I wanted was to add a timestamp for when the program was posted. For that, I need to add a variable called date, a type of variable type date called now. And here, instead of saying just if true, this is how you enable basically another rotary axis in the Fusion Autodesk documentation. You will see if true. This is not quite okay. So I condition that variable with my has a fourth axis. So only if it has a fourth axis, it will output, it will enter this code and do the setup for the fourth axis. Next, what I've done here is the timestamp that I'm posting. I'm gonna show you in a minute how the code looks like with my tool, with these settings and with this tool info. Okay, so we have the time posted, and I'm gonna post date, month, and hours, minutes. And also what I changed was how the tool is being displayed at the top of the program. So I want the diameter, I want the fluids, I want the corner radius, and then I'm displaying how far down it's gonna go, so Z minimum. Okay, and we can go to the bottom of the program. So here we have if is multi-axis, and I'm just commenting that G49. I don't know why it was there, but I crashed my machine. And at the end of the program, one change that I wanted was that I wanted to stop the spindle when I know it's the same thing, it's M5, yeah. So I wanted to stop the spindle when the program is finished and then retract. And also what I've done, I've said if you have a go to predefined position set to true, write a G30. So go to that predefined position. Okay, so now I'm gonna show you how a program that output with this post processor will look like. So if I go there, we have an optional fourth axis. Let's say I click go to predefined positions. We have all these three on. Overwrite. Okay. So we have a G45, a G64 with P001. So this sets the tolerance to 100 of a millimeter. Then we have an A0 because I said that I have a fourth axis. We don't have any G49, which is what I was expecting. And at the end of a program, I have a G30, which will position the table at the place that I want after the Z was raised, the Z axis was raised. Okay, so these were the changes that I've made. I've accomplished my goal. So if you need my post processor, here is it. Here it is. I'm gonna post it in the description. You can use it as you want on your own risk. Okay, so in the first part of the video, I told you that I've made two mistakes. One of them was related to fusion. I mean, that was not quite my mistake. That was a fusion error, but I paid the price. And the second one, there was something that I could have done better, and that's what I'm gonna talk about now. So I'm gonna talk about how my machine is wired internally in this cabinet, and how this is all communicating together. So first we have LinuxCNC PC with a real-time kernel. This is the one, and then we have this is the PC, and inside this box there is a Mesa card, which is Mesa 7i76E, E from Ethernet. These two are communicating via Ethernet. And now I'm going to explain how is everything wired. So the spindle driver is communicating with this board via an analog 0-10 volt, and it has a feedback from an encoder, but I'm going to talk about feedback later. So it has an analog 0-10 volts which commands the spindle, and the spindle is linked to the motor. From that motor I have a feedback with a resolver that enters into the spindle driver, and the spindle driver has a plug-in card. It's a Delta C2000, and that card transforms the resolver input into an encoder input, which is fed to Mesa. This allows me to do rigid taping. That's the reason why I wanted LinuxCNC and not Mach 3, because with Mach 3 you cannot do that, and you need a real-time kernel to compute the spindle pulses of the motor in order to do rigid taping. Tested, works fine. Okay, then so this is analog 0-10 volts, and then we have the driver for the axis. These are commanded via pulse width modulation, PWM, square signal. So the driver it's a closed loop servo. It communicates with the motor, and it has a feedback. So basically the driver right now closes the velocity and position loop. So basically the driver knows where the motor is, and it ensures that is where it should be. Okay, so in this diagram, this is how it is now. In this diagram there is a problem, and if that problem was sorted out okay from the beginning, I could have avoided the second crash. So I had two crashes. The first crash was caused by fusion. So at that time, this tool that no longer has a collet because I destroyed it, bumped into this part and leave this mark, and then I wanted to home the machine, and okay, so I turned this power off and turn it back on too quickly. So when I had the first crash, the Z driver faulted and the spindle driver faulted. So I restarted the machine and wanted to do a homing. And at that point, I didn't notice that this was closed. I didn't notice that the spindle driver exit out of the fault, but the Z-axis driver was still in fault. So I hit home. On the display the machine was homing, but in reality it was not. So it was still stuck here. And me, stupid enough, I did not press the stop button. I opened this to look what's happening, why it's not moving, and at that time, due to a LinuxCNC bug, it started homing on X and Y. So that was the point when it bumped the tool sideways into the fourth axis. So that should never happen, and that's the issue that I'm gonna talk next. So The problem here is that into this Mesa board, I have no feedback, I have no error feedback. So what I would need, these are the changes that I need to make. So this spindle driver has another pin, which is the error feedback. So if the spindle encounters an error, LinuxCNC should notice and stop everything. If a driver encounters an error, LinuxCNC should know and stop everything. So right now, what I need to do is feed this into Mesa. So if I would have that, in my case, if Z driver was still in fault, nothing would have happened because it would not have started, because it would have noticed that it's in fault. That's a problem that I'm going to address, but I haven't managed yet how to get the servo error out of the drive. I'm gonna make another video showing what I tried to do and why I didn't make it. And the next thing I want to do is add a 7i85 board. So this is another board that connects to this one, and this is an encoder interface. So right now, LinuxCNC has no idea. So yes, I'm gonna have the error, but LinuxCNC does not know. LinuxCNC relies on the fact that the driver has the capability to close the position loop, but in fact has no idea where the driver is and has no idea where the motion is. So what I'm gonna do, I'm gonna input the encoder. I'm gonna draw that with green. So I need to input the encoder from each of these axes into this Mesa 7i85, which is an encoder interface. I need to add an extra board because this one does not have encoder inputs. I mean, it has one for spindle, but that's it. If you're building a new machine and you need encoder inputs, and I would recommend you encoder inputs if your drive have, and mine have, I would recommend you a 7995. A 7995 board is basically a Mesa 7i76 that has encoder inputs. So that's a board that has both of them. I don't know exactly if when I ordered this, which was about 3 years ago or something, this was already on the market, but I had no idea about it. So this is already ordered, this board. So I'm gonna link them together. So I'm gonna have like two mechanisms. One of them will be error feedback being outputted to the Mesa, and the other one will be the position of each driver. Each driver gives me an emulated encoder output, which acts basically, I think it just forwards the encoder from the motor to whatever consumer you need. So I'm gonna output that encoder signal and close the loop in LinuxCNC. So at that point, if that would have happened, I would have got joint following error. I'm retrofitting a machine now, a Traub mill, and fortunately now, unfortunately when I started, that machine has it's an absolute, it has analog drives. So LinuxCNC was closing the loops. So in that case, on that machine, that would my crash would have never happened, the second one, because when I wanted to do the homing and the motors were not moving, LinuxCNC could notice that, hey, the motor is not moving, stop everything. Okay, so lesson learned. I learned how to make my machine better. I did not made it like this from the beginning because I got comfortable, and Fortunately, nothing got damaged to bad, so I can fix that problem now. Hope it helps those who are in this niche of building machines and making the machines smarter. Thank you.